Hello everyone and welcome. In today's video, we're going to dive into 3D CAD automation and we'll be using Autodesk Inventor as an example. But keep in mind, the same approach can be applied to other 3D design software as well. Automation can save a huge amount of time and effort in your design process. And in this video, I'll be showing you some of the most useful areas where it can make a difference. Here's what automation includes. Parts and assembly resize. With just a few dimensions changed, all parts, assemblies and drawings are automatically updated. Export to PDF. Export all drawings to PDF at once, automatically organized by sheet size and merged together. Sheet metal DXF and STEP files. Generate all DXF and STEP files for sheet parts at once, along with an Excel file containing sheet part information organized by material, surface finish, and thickness. Properties and quantity. Update properties and quantities for all parts and assemblies with a single click. Bill of materials. Automatically update and manage your component lists. Sheet cut optimization. Get the most efficient sheet cut layout to reduce waste. Site packing list. Import all part names and quantities directly from Inventor. Add manual parts if needed and export everything to Excel. Now, to demonstrate how this automation actually works, we'll be using this trolley model as our example. This model is perfect for showing the workflow because it contains different parts, assemblies, and drawings. With this trolley, we'll go step by step through the automation process, resizing, exporting PDFs, generating DXF and STEP files, updating properties, and even preparing bill of materials and packing lists. This way, you'll see exactly how automation saves time and reduces repetitive manual work in a real-world design. Let's see how automation helps with assembly and part updates. We'll go to our software, choose the model we want to update, and simply change the dimensions. With just this adjustment, all related parts, assemblies, and drawings are automatically updated. This means no need to manually edit each file. The entire model adapts instantly, saving time and avoiding mistakes. Now let's move on to properties and quantities setup and exporting the bill of materials to Excel. First, we'll choose the folders that contain our parts and assemblies. Then, we'll select all the components for which we want to add or update properties and quantities. After that, we can pick a specific assembly and automatically calculate the total quantity of all parts inside it. Once this is complete, we'll export the bill of materials as an Excel file. The bill of materials clearly lists all parts and their quantities for the chosen assembly, ready to use for documentation or manufacturing. Now let's take a look at our updated model. All parts and assemblies have been updated to the dimensions we have set. You can also see that the dimensions, quantities, and drawings have all been successfully updated. Everything is synchronized automatically, keeping the model, assemblies, and documentation consistent without any extra manual work. In the next step, we'll export the drawings to PDF and all sheet metal parts to DXF and STEP files. First, we'll choose the folders where our drawings and sheet metal parts are located. Then, we'll set how we want the drawings to be exported. After that, we'll select the output folders for both the drawings and the sheet metal parts. Finally, with a single click, we'll export everything. Now, let's go and check the exported PDF drawings. You can see that they have been organized in folders by sheet size and merged into files accordingly. In addition, the sheet drawings are organized in folders by material, surface finish, and thickness. We also have a sheet structure file that clearly shows which drawings belong to each material, surface finish, and thickness. This organization makes it very easy to locate and manage all your drawings and sheet parts. Now, let's check the exported sheet metal DXF and STEP files. In this folder, all flat patterns, you'll find all DXF and STEP files saved together, along with an Excel file containing information about every sheet metal part. In the second folder, Organized Flat Patterns, the DXF and STEP files are neatly organized by material, surface finish, and thickness. Next, we'll use sheet cut optimization. First, we'll import the sheet metal parts from the Excel file we created earlier. Then, we'll specify the sheet size we want to use and run the optimization. The software calculates the optimal use of sheets and generates a PDF report. This report shows exactly how many sheets are needed, their sizes, and the placement of each part on every sheet. This ensures efficient material usage and helps plan production with minimal waste. Lastly, we have the site packing list. Here we can import all part names and quantities directly from Inventor, or add items manually if needed. And then save everything as an Excel file. This provides a complete and accurate packing list, ready for site use or documentation. Before we wrap up, I would like to mention that our software can be easily integrated with procurement systems, ERP platforms, or any other system you may already be using. And to make sure you're never left without help, an assistant is available 24/7 to support you whenever you need it. Thank you all for watching. I hope this video gave you a clear look at how 3D CAD software automation can save time and make your workflow more efficient. If you have any questions or want to learn more, feel free to contact us.